you. So, hello together. I'm Max, and I welcome you to my presentation. The core element today will be the relatively new AnyLogic transporter, which was released in version 8.3. And I want to talk with you about how to optimize fleet operations like the allocation of tasks to transporters. Let's take a short look at the agenda. Initially, I want you to know what you can expect from this presentation today. Then I will tell you about the current standard practice in industry for allocating tasks to transporters, followed by my method to customize the allocation of tasks for the AnyLogic transporter. Finally, I will show you two live demonstrations where you can see the actual algorithm working, and I will show you an analysis of the gained improvement in the AnyLogic cloud. So what can you expect today from this presentation? I want you to understand the standard AnyLogic transporter resource choice options, and they are corresponding to the current industry standard, more or less. Furthermore, I want to teach you how to gain flexibility in the AnyLogic transporter choice to suit a more complex logic. And I want you to understand how much performance you can win when applying such optimization. Sorry. So for those of you who don't know what the AnyLogic transporter is actually doing, the most simplified description might be that the transporter brings a pallet from one place to another. The corresponding processes are called the pickup process, where the vehicle drives to the pallet, and the delivery process, where the pallet will be brought somewhere else. So if we take a look at the move by transporter block, which essentially is the heart of the transporter process, you can take a look at the dispatching policies, and there AnyLogic offers 5 different policies. So let's go through these policies. The first is called nearest to agent, and this policy will evaluate the distance between a transport mission and a corresponding transporter. The distance will be measured as a straight line or B-line, so it will not involve the actual path the vehicle has to drive. The second option is called shortest path to pickup location, and this method will involve the actual path a vehicle has to drive. The third option compares two vehicles with a specific value. The fourth option will evaluate all idle vehicles with something like a calculation algorithm, which can be specified. And the last option turns the dispatching policy off, and therefore I think a random transporter or the first found transporter will be chosen. Okay. So what do these methods have in common? They are all more or less simple priority rules. They do only consider idle vehicles. Idle means that they don't are that they are not involved in any other task, and they do not consider interdependencies, and interdependencies are more occurring for large systems. That's important to know. So if you consider a large system, let's say above 30 vehicles, the amount of interdependencies is growing significantly. And for a system with 100 vehicles, you may have even more interdependencies. So how can we customize this transporter choice? If we take a look again into the move by transporter block, we will find the option to customize the transporter choice. And if we switch it on, we see a condition that we are able to specify a condition, which has the expression of to be a Boolean. And if we take a look at the small yellow light bulb, we can see which objects we can use in this field. And for us important here is the agent, which refers to the transport task in the move by transporter block. And also important is the unit which represents uh, to be evaluated transporter. So the unit refers to any transporter in the fleet. And if we type something like unit equals find unit and in brackets agent, we can specify a function here in the example named find unit, where the function will evaluate one specific transporter for a specific agent. And here we can specify our own logic to find a transporter. The dispatching policy can be turned off in this case because we will only find one specific transporter. What does this method brings to us? It enables the integration of not only idle vehicles, but also already assigned vehicles and currently delivering transporters in our decision. And that's important because these two groups, also so the groups of pickup vehicles and delivery vehicles, is quite large for a high utilized system, and therefore it gives us a lot of flexibility. The second point is that if you decide to make reassignments, so this means that you want to reassign vehicles that are currently in the pickup process, so they don't have the pallet on top, but they are going to drive to this pallet. If you want to have these reassignments, it's important to add a re-enter in front of the or before the move by transporter block to re-evaluate this change decisions. So whenever you decide to give a pickup vehicle a new mission, you have to take this former mission, the original mission, and put it into the re-enter block to cancel old the old assignment. That's a little bit trickier. That's something you might have to play a little bit before it works well, but it's important to know. So with this method, you can add a custom calculation with the find unit expression, and you can evaluate any measurements you want. You can measure the distance by route to an agent. You can measure the distance by time, which might also involve process times or any other value. And that's where you are completely flexible to anything you want to do. So the optimization objects at BMW were first or most important to have no late tasks. So this was the overall goal. And we wanted to have to minimize the traffic density. At BMW and maybe all other car manufacturers, the pathways are very high utilized, not only by HEVs or AMRs, but also by route trains, by bicycles, by people, by anything. And therefore, we want our AMRs to have as less to occur as less traffic as possible. So overall, the second priority is to minimize the traffic density, and that means that we want to meet the goal of no late task with a minimum of transporters driving effort. So in academia, this problem is described as the assignment problem. The matrix you can see here describes the relation of two groups to each other. In our case, these are vehicles on the left side and on the y-axis, the tasks. The values in between represent some kind of efforts or costs in the system, and these values can express different things. So maybe in a very easy way, they can only express the meters a vehicle to drive. For example, the vehicle 1 has to drive 200 meters to catch up the task 1, but they can also be a formula which also involves maybe the current state of the vehicle, its battery charge, its state of charge, maybe its current status in terms of, is it picking some other task or not? Is it idle? Is it in a charging station? So here you are completely free to define your own specific formula. And the goal of this assignment problem is to find a maximum number of pairs and minimize the total effort. And here you see exemplary one solution, or the optimal solution. And what I want to highlight here is that, for example, for vehicle 2, not the task 3, where vehicle 2 has only, let's say, 30 meters to drive, but task 2 is chosen in order to fit the overall goal of minimizing the total effort. So how can we solve this problem? There are two groups of methods. On the left, we have the exact methods, which always find the optimal value, and on the right side we have the heuristics, which are more or less approximation methods. They are usually faster but not that accurate. For the evaluation of all method, I used AnyLogic as well, but due to the time constraint of this presentation, I only want to refer you to ResearchGate if you are interested in this study. So in this study, I found out the JVC algorithm to be superior to all other methods, and I use this algorithm in my simulation model, which will be presented now. So let's take a look at the actual model. So I'm currently on my desktop, not in the AnyLogic cloud. The cloud presentation will be afterwards. So let's take a look in the model itself. I will shortly explain what you can see here. So we have a layout where we have three areas of warehouses. So on the left we have a warehouse, down we have a warehouse, and on the right there will be empty bins. There will be the place for empty bins. The houses are representing parking stations. The green dots are representing charging stations. And these dots are representing places where goods are needed. So at BMW, we call these points fit points. These are the points where the articles will be built in the cars. And if we take a look, for example, at this vehicle, so this vehicle has a mission here. It has to drive to this mission. And what we now want to see is how the algorithm actually is working, and therefore we can have a look at the matrix. And the matrix is made of the missions on the top side and the vehicles on the x-axis. And the values in between, the formula behind this is my personal secret, to be honest, but you can imagine these costs to be something like an effort the system will have when a specific vehicle will do a specific task. And with the highlights, you see the actual solution the algorithm is choosing. So if we start the system utilizing, we will get a lot of more missions to make. And then if we take a look at our matrix, the matrix size increases. So now we have something like 30 missions and 40 vehicles, and you see the matrix size increases, but the system is still able to find a solution very fast. So it runs in milliseconds. And on the left side, you can see the actual assignment of the vehicles to the missions. So you may now wonder of how much performance can be won by optimizing the overall system. So not only use the nearest agent first logic, which is applied in industry mostly. And for that, I want to show you my AnyLogic cloud model. The model is public, so you can find it if you look for flexible task allocation and AMR or something. It still was the model of the month of this year's February, by the way. And yeah, now I want to have a look in this model. And therefore, I have a parameter experiment which has different numbers of AMRs between 40 and 60. All other parameters are fixed, and it evaluates, for this case, the count or the amount of late tasks. And as you can see, when we have only 40 vehicles, we have a huge amount of late tasks. By the way, we are totally simulating 7,500 tasks to make. And with the experiment of 40 vehicles, we have 2,700 late tasks. And when we have around 58 vehicles, we have almost no late tasks. So we have here 3. And if we compare this model with our extended strategy, which is made of the um, assignment problem, let's take a look how this will look. 1 second, I make it a little bit more easy to read. So um, I'm blind for colors, so I think this is red or brown or something. So you can see that the optimized method needs 42 vehicles to have only 3 late tasks. And in comparison with the original method, which needs, yeah, let's say 58 vehicles for 3 late tasks, the improvement is, or you can save almost 30% of the whole vehicle fleet. So it's 58 vehicles versus 42 vehicles, which is, I think, a huge amount if you consider the high costs of an AMR. Yeah, it's a lot of it's a high improvement for such an easy software-driven optimization. Um, what else does the system improve? It gains a lot of more flexibility. So if you have orders which are, let's call it, priority orders, the optimized system can handle these orders in a very fast way because it has a continuous optimization. So every 20 seconds, I calculate a new solution using the assignment problem. So I hope this presentation has given you an idea of how you can flexibilize the AnyLogic transporter. And now I'm looking forward to your questions, and thank you for your your looking here. Thank you.
Thank you, Max. Oh, that's very in detail and very interesting. Uh, they, as the questions coming in, I was just wondering, maybe it was something that got addressed early on and perhaps is easy to miss. Is what drove you to choose the cloud platform for
Um,
modern?
Yeah, actually, it was the huge amount of time I need for for one or for a parameters variation, because if I simulate, let's say, around 40 different fleet sizes, one simulation experiment takes around, let's say, so I'm simulating 9 hours. It takes around 2 hours actually, so relatively long, especially when I use in the model a stress test. So I have very large amount of orders to test my prioritization method. And in this case, the algorithm um, takes takes a lot of time to calculate the solution because the amount of missions is like 200, 300 missions at a time. And that's why I use the cloud, because I can do a lot of simultaneous simulations, and I can simply switch the computer off and check it via smartphone when it's done. That's very comfortable for me. And also the results, so the presentation of the results is quite easy. You do it once and you can use it frequently. That's very easy for me to
Am
have.
I right to say that there is a version of this model available
Yes, it is.
publicly? Yes, there is.
Yeah,
We can get that link out to people.
sure.
Okay. Um, so there's a question here. Is the congestion among the transporters considered within the model?
The sorry, can you repeat it? The
So is the
congestion?
congestion of the transporters considered during the run of the model?
Yes. Also,
Yeah,
of course, that's the that's
the whole.
how the transporter is modeled, right?
Yeah, so
Yeah,
they
it is.
automatically do it as
Yeah,
part of their
yeah, yeah.
normal operations.
Yes.
Uh, so how do AGVs pick up the pallets with the cargo from a movable table or from a pedestal?
It's so in the for the simulation, it doesn't matter, to be honest, because there is a X and Y position where the transporter has to pick it up. And in regards to our projects, we have something like how do we call it? So the most pallets are on wheels, and the HV is that flat that it can drive below and lift it up. And in some cases, we have something like a steel case where the pallet is hanging and the HV can drive below.
Okay, so they don't transport the tables themselves in
They transport
or
the pallets.
the pallets themselves. Uh-huh.
But the pallets are not made of wood like common pallets. It's like a steel case, actually, a steel case on wheels.
Okay,
I was just talking about pallets to make it easy to understand, to be honest.
all right, thank you. Yeah,
Okay.
no, that's great. Luigi Manca here is asking, well, first of all, saying very impressive, thank you. But did you get any infeasible solutions from the optimization algorithm?
No, no, because let me just think about this question. No, because it's not possible to get any infeasible solutions because I'm looking for combinations in the matrix, and the one constraint is that one mission or one vehicle can only chosen once, and therefore this constraint ensures that there will be no infeasible solution.
Okay.
I hope
As-
this met this question, or I don't know.
I
If
hope
not,
that that answers the question,
yeah,
Luigi.
okay.
Yeah. Um, Vera is asking, so okay, we've got AGVs and AMRs here, but what do you think could be the effect? Like, what do you think about using forklift robots? Could they be more effective?
It depends on the use case, I guess. So forklifts are usually made to, or are maybe better to lift very heavy goods. So in an automotive production environment, this might be motors. So if a or engine, not motor, if an engine might be heavier than 1,000 kilograms or not, I don't know. So the BMW AMR is able to lift up to 1,000 kilograms, and to my knowledge, only some engines are do have a higher weight than 1,000 kilograms.
Yeah, that's quite
And
high already, isn't it?
yeah,
Yeah.
it is. And the AMR has the advantage that it's a lot of it's smaller than a forklift. Yeah? A forklift is the forklift and the fork below in front, and the HEV has its forklift on the upper side, so it's more compact.
Could be more congestion with the.
Yes, correct.
You have to redo the model. A question just coming in at the end here. Uh, Again, saying very nice model. Thank you for sharing it with us. From Anastasia is asking, does the reassignment process also include the priority of a particular task?
Yeah, very good question. But this question will be, also yes, it does, to be short. But the priority process is very complex. The priority process ensures that no missions are getting late. And therefore, I want to refer the people who are interested in this in one contribution, which can be found on ResearchGate or on my personal homepage, and it tackles the topic of prioritization in such a system. It's not easy to explain. It's an important part of the task allocation, but due to the time constraint of this presentation, I was not able to talk about this, to be honest. But there is a paper about this where everything is explained in detail.
And we can find that on your.
Yes, you can find it here. So
I understand we have a few extra minutes, so maybe we can bring it to screen or share it back in the.
I'm
Oh,
sharing currently. Yes.
there it is. There we
Yeah.
are.
Genau.
Okay, so Anastasia, that's the place you need to go for more detail on that.
Correct. Correct.
Thank you very much. Okay,
You're welcome.
so if that's just checking for any last minute questions, I believe that's it for now. But if people want to catch up,
Sure.
um, they'll
Uh,
be able to find you on the platform.
Sure. I'm
Just
always looking forward to any discussion or networking to this topic. Feel free
fantastic.
to contact me.